happen if our Earth's magnetic field disappeared? We notice that that's happening exactly as space weather is showing. In the past 5 years, it's gone down at least 18%. Why is that happening? That's not good. But it wouldn't be like a disaster movie. That's according to Stephanie Pappas of Live Science. Extending from Earth, like invisible spaghetti, planet's magnetic field, as NASA shows us in the diagrams, created by the churning of Earth's core. The field is important for everyday life because it shields our planet from solar particles, and it provides the basis for navigation, and it might have played an important role in the evolution of life on Earth as well. But what would happen if Earth's magnetic field disappeared tomorrow? A larger number of charged solar particles would be freer to bombard into our planet, putting power grid satellites on the frizz, increasing human exposure to high levels of cancer-causing ultraviolet radiation. It's not only the cosmic rays that would be bad for us, also the solar radiation. In other words, a missing magnetic field would have consequences that would be problematic, not necessarily apocalyptic, at least in the short term. In the long term, of course, they would be devastating. The good news is that because for more than a century it's been weakening, now there are specific, especially flimsy spots like the South Atlantic anomaly in the southern hemisphere, which create technical problems for low orbiting satellites. We know that the satellites have to turn off whenever they go over that area so they don't have any damage. The first thing to understand about the magnetic field is that if it is weakening, it's not going to disappear, at least not for billions of years. Earth owes its magnetic field to its molten outer core, which is made mostly of iron and nickel. The churning outer core is powered by the convection of heat released as the inner core grows and solidifies. This is what John Tarduno explains. He's a geophysicist at the University of Rochester. The inner core grows by about 1 millimeter per year. How does it grow? This magnetic field engine, known as the dynamo, has been chugging along for billions of years. Scientists think that the current core arrangement may have settled into place about 1.5 billion years ago, according to 2015 research that found a leap in the magnetic field strength around then. But Tarduno and his team found evidence for a magnetic field on Earth in the planet's oldest minerals, the zircons, dating back 4.2 billion years, suggesting that activity in the core has been creating magnetism for a very long time. It isn't clear why the dynamo got started, though it's possible that the enormous planetary impact that created the moon might have been the key driver. This is what Tarduno explains. This impact, which occurred about 100 million years after Earth came together, could have shaken up any stratification or layering of materials in Earth's core. You can imagine shaking up a bottle of oil and water on a planetary scale. This disruption could have promoted the convection that still drives Earth's dynamo today. And eventually the inner core will probably grow large enough that convection in the outer core is no longer efficient and the magnetic field will fail. But that scenario is so far off that it's not worth losing much sleep over. Tarduno said that we're talking billions of years here. Now the weakening magnetic field, far more relevant to the lives of humans, of course, is a magnetic field weakening. Scientists have been measuring this weakening directly with magnetic observations and satellites for the past 160 years. Whether the field was faltering before that is a bit murkier, as is what it will do next. The magnetic field is currently about 80% dipolar, Tarduno said, which means that it acts almost like a bar magnet. If you could put iron filings around the planet and remove the influence of the sun, which spews constant stream of charged particles called the solar wind towards our Earth, blowing the magnetic field around like long hair in a breeze, the resulting magnetic field lines would show a clear north and south pattern. But 20% of the field is non-bipolar, meaning that it's more complicated. There are local variations in it. In the past, the magnetic field has flipped, swapping north and south poles. At least of these reversals, the last of them happened 780,000 years ago, around the era of Homo erectus. Weakening of the field has typically preceded these flips, raising questions about whether another flip-flop is imminent. But the field also weakens at times and then strengthens again without flipping, the phenomenon called an excursion. Tarduno and his team found that a weird eddy in the core under South Africa might be contributing to some of this weakness. This eddy appears to cause the South Atlantic anomaly. It's a known weak spot in the field that stretches from about 190 miles east of Brazil across much of South America. In this area, charged particles from the solar wind dip down closer than usual to Earth. The South Atlantic anomaly is not particularly noticeable on the ground, but Earth-orbiting satellites encounter more damaging solar particles there. And astronauts who have traveled through the region on the International Space Station have reported shooting star visual phenomena thought to be caused by relatively high levels of radiation at the level of low Earth orbit right there. A field-free Earth? Tarduno and his team suspect that the variation in the mantle under South Africa might have been the trigger point for magnetic field reversals in the past. The good news is that even if the field is weakening or prepared to flip, it's not going to disappear. There's no evidence that the magnetic field has ever gone away completely during a pole reversal, a magnetic reversal. Now, even if the fields reverse, we'll still have some magnetic field present. It just is going to be a very weak magnetic field, Tarduno said. What would this world be with a minimum magnetic field, and how would it look like? Well, your compass for one would not work, and that's just going to be the pointing towards the region of the highest magnetic field. It could be very close to you, it could be very far from you, Tarduno said. The northern and southern lights would be visible from lower altitudes because these colorful show that they result from the interaction between charged particles hurled from the sun and the solar wind and Earth's magnetosphere. Right now, these auroras appear near the poles, following Earth's largely north and south magnetic field lines. But a weaker field would allow the particles to penetrate Earth's atmosphere, lighting up the sky closer to the equator. The conditions in the South Atlantic anomaly for satellites might become common across the globe, which would cause technical glitches. Solar particles can ping electronics, disrupting bits of memory in what are called single event upsets, or SEUs. When solar particles interact with the charged layer of Earth's atmosphere called the ionosphere, they also knock electrons free from their molecular orbits, and these free electrons then interfere with the transmission of the high-frequency radio waves used for communication. Interaction between the solar wind and Earth's atmosphere can also break down the ozone layer over time, Tarduno said, which would raise humanity's collective ultraviolet radiation exposure and increase skin cancer risks. He said whilst it probably would not be utterly catastrophic for life, there would be a much higher radiation dosage on the ground without a magnetic field. This is what Martin Archer said, space plasma physicist at Queen Mary University of London. There's a little evidence that past magnetic field variations have impacted life on Earth. Still, the magnetic field has undoubtedly shaped Earth's surface, helping to keep the planet's fragile atmosphere from being blown into space, blown there by the relentless force of the solar wind, of course. This is what Archer explained. The magnetic field is not crucial for having an atmosphere. Venus has no magnetic field and has a massive, if unwelcoming, atmosphere, but it certainly acts as an additional protection layer. Mars, which used to have a magnetic field but lost it about 4 billion years ago, has had its atmosphere almost entirely stripped away. And if there were a way to give the Moon an Earth-like atmosphere, the solar wind would whittle it to nothing in a mere century, Archer said. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.